Okay, let's look at TEK 4.3d. I can compare two fractions with different numerators and different denominators and represent the comparison using less than, greater than, or equal to. Let's look at a basic example with same denominators. So here's 3/5. That means 3 out of 5 are shaded in. Here's 2/5. That means 2 out of 5 are shaded in. So it's very easy to know that 3/5 is more than 2/5 because 3/5 has one more piece shaded in. So I would use my greater than symbol to show 3/5 is more. The numerator is the top number and the denominator is the bottom number. So here's an example where the numerators are different and the denominators. So there is a series of steps that you have to go through in order to figure this out. But first, I'm going to show you why we have to do those steps. So this will involve using tracing paper and a fraction board, like this. Tracing paper and a fraction board. So the fraction was 2/3 compared to 3/5. So to do that, I'm going to find 2/3 on here. It's right here. And I'm going to just trace it with my patty paper or tracing paper. Very carefully. Try to stay as accurate as possible. So that's 2/3. And then I'm going to compare it with 3/5. So right here, I'm going to move the patty paper down to 3/5 and trace that. And from this patty paper, I can tell that 2/3 is more than 3/5. Now, so because I know 2/3 is more than 3/5, I'm going to draw the greater than symbol. Let's do another example. How about 4/6 and 6/8? So 4/6 compared to 6/8. So right here is my eighths. 1, 2, 3, 4, 5, 6/8. So looking at this, I can tell 4/6 is less than 6/8. So then on here, I can draw the symbol that way to show 6/8 is greater than 4/6. Let's look at another example, 1/2 or 3/5. Okay, so find 1/2, trace it as carefully as possible. I'm going to go ahead and label it. And then compare it to 3/5. Now, we know that 3/5 is more than 1/2. But here's what I want you to look at. I'm going to move these down, and I want you to look through the patty paper and see if you can find other fractions that line up with it. So like I'm going to move it to the 6ths. If you notice, the 6ths lines are not aligning. Like I have 3/6 that equal to 1/2, but the 5ths are not matching up. So let's do 8ths. The 5ths are not matching up with the 8ths. Like 3/5 is not equivalent to anything in 8ths. But with 1/2, 4/8 matches up. I'm looking for a perfect match. Let's look at tenths. 5/10 equals 1/2. And what do you know? 6/10 is equal to 3/5. This is very important to help us solve which one is greater when we don't have pictures. So let me explain that again. If you look, here's the thirds. I have 1/3 over here, but then 2/3 doesn't equal to anything in the half. So it won't matter. I can't use thirds to help me with this. Fourths. 2/4 equal 1/2, but then with fifths, there's not a matchup. Fifths, obviously, I have 3/5, but then the half won't fit in the fifths. So when I got down here, I noticed 5/10 equals 1/2, and 6/10 equals 3/5. So keeping that in mind, what I basically just did was I found equivalent fractions for half and 3/5. 1/2 is equivalent to 5/10, and 3/5 is equivalent to 6/10. So now it is so much easier to determine which one is greater. Now, I was able to do these because I had pictures. I knew that from the pictures. But our goal is to step away from pictures and be able to figure this out using equivalent fractions. Now, you're wondering, well, I didn't know what was equivalent to it because I had to the only way I could do it was through tracing paper. But there is actually a way to find equivalent fractions and knowing which equivalent fraction to use. So that's what I'm going to explain in the next video. So on the fraction board, we figured out that these both have equivalent fractions in tenths. We figured that out through the tracing paper, but you can figure it out without using tracing paper. All you have to do is you take the denominator and you skip count. You skip count maybe the first 5 or 10, and you should find a number they have in common. So this doesn't have 5, but this one has 5. This doesn't have 2, but this has 2. 4, 6, 8, 10. They both have 10 in common, which means I could take halves and cut them into tenths, and I could take fifths and cut them into tenths. That's all you're doing. You're just finding a multiple. And you know what? This part is so easy, this part here, because we did equivalent fractions in my other videos. You got to do, well, 2 times 5 equals 10, so 1 times 5 equals 5. 5 times 3 equals 10, 3 times 3 equals 5 times 2 equals 10. 3 times 2 equals 6. And now it's so much easier to compare 6/10 to 5/10. Let's look at another example. All right, let's compare 1/2 to 2/3. Okay, so I'm going to take my tracing paper and I'm going to trace 1/2. And then right underneath it is, 2/3. Okay, I'm going to move this paper down and I'm going to see which one of these will also have an equivalent fraction with both of them. If it just works for one and it doesn't work for the other, we can't use it. Okay, so I'm going to move the half over the third. Actually, let me label these so it'll be easier. So here's my thirds right here, the thirds, and I put the patty paper, the half patty paper over it, and notice nothing in thirds is equivalent to half. So I'm not going to use thirds. How about fourths? Well, look at that. 2/4 is equivalent to half. So let's check if thirds also match up somehow. Unfortunately not. If you see right here, this is the 3/4 mark and 2/3 is short of it. Let's try fifths. Let's see. Half does not match up anywhere in fifths. Neither does the thirds. Let's try sixths. Right here. That works. 3/6 is equivalent to half. So, well, what do you know? 1, 2, 3, 4, 6 is equivalent to 2/3. I can use sixths and change these both to sixths and see which one is more. Now we know from tracing which one is more, but the purpose of this is for you to get away from pictures and understand why we find equivalent fractions. So we said 1/2 is equivalent to 3/6, and we said 2/3 is equivalent to 4/6. So now it's so much easier. 4/6 is greater than 3/6, therefore 2/3 is greater than 1/2. Now let's look at figuring this out using the multiples. Okay, so you want to take the denominator and skip count. 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 15. So based on this, I see that they both have 6 in common. So I'm going to find the equivalent fraction as if it were in sixths. And you should be able to easily figure that out. So 3/6 compared to 4/6, we know 4/6 is greater, so 2/3 is greater than 1/2. It's so easy that you won't even need pictures. You can easily do these without it.